You're looking at pgvector, right? Thinking you can just store embeddings in Postgres instead of adding another database to your stack?
Yeah, Postgres is already there, and all our vectors map to relational data anyway. Does it actually work in production?
It works. But there are trade-offs you need to know about. Let's go through what pgvector actually does well and where it starts to break down.
So pgvector gives you a vector column type. You can store embeddings directly in your table, up to 16,000 dimensions.
Right. It handles cosine distance, L2, inner product, all the standard metrics. And those vectors sit in the same row as your metadata. No separate service, no joins across systems.
That's exactly why we're interested. Embedding search filtered by user ID or timestamp, it's just a where clause.
Here's what the syntax looks like. You install the pgvector extension, then declare the vector type with the dimension count, same as any other column.
And you insert arrays or cast from text. Pretty straightforward. Okay, once you've got vectors in there, you need an index, or every search scans the whole table. pgvector gives you two main index options, HNSW and IVFFlat. Without an index, you're doing brute force scanning across every row.
HNSW builds a graph index. Better recall, good for most cases, but it's slow to build and eats more memory. IVFFlat splits vectors into partitions, faster to build, lighter on memory, but you lose some recall.
And with IVFFlat, you're setting the lists parameter when you create it, then tuning probes at query time. HNSW has M and EF construction for the build, EF search for queries.
Honestly? Start with HNSW unless you're really tight on memory or you can tolerate lower recall. This is where it gets interesting. You can filter by user ID or any other column, then do vector search on just that subset. The tn-step operator calculates Euclidean distance between vectors when using pgvector.
Wait, if the planner decides to scan the filter first, your vector index never even gets touched. Explain shows exactly that happening.
Yep. You fix it with a B-tree index on the filter column and include the embedding, or you use a CTE to force the vector index scan first. This is where pgvector's query planning can really hurt you.
So you're reading query plans and rewriting SQL. Not quite as automatic as a dedicated vector database's filtered search.
By the way, my DBA's free health check catches exactly this kind of missing index automatically, and it gives you the actual create index statement you need.
Oh, that's useful. So it's not generic advice, it's the specific SQL for your schema. All right, where does pgvector actually fall short compared to something like Qdrant or Pinecone?
Scale is the biggest one. Tens of millions of vectors. pgvector handles it. Hundreds of millions. Dedicated stores shard and distribute way better. Latency is fine for modest datasets, but those systems are purpose-built for sub-10 millisecond P95 at massive scale.
And operationally, you're trading one fewer service for Postgres now carrying your vector workload. So vacuuming, memory tuning, connection pooling, all of that suddenly matters more.
Exactly. You also lose vector-native features like auto-tuned recall, hybrid search, re-ranking, but you get transactions, foreign keys, the full power of SQL. It's a real trade-off, not one clear winner. Whether you're running pgvector or anything else, my DBA's free health check scans your database across 16 domains, indexes, queries, vacuum, config, all of it, and gives you the exact fixes.
Connect your own database at mydba.dev. You'll get a full report in minutes, with deeper insights every week. It's free, and it's built for engineers who want specifics, not guesses.